In this lesson, we will be proving and applying theorems about the special triangles that are isosceles and equilateral. Before we start proving theorems about these triangles, we need to review some vocabulary. So first of all, an isosceles triangle is a triangle that has at least two congruent sides. The two congruent sides are called the legs of the isosceles triangle. And the third side is called the base. The two angles that touch the base are called the base angles. And the top is called the vertex, and this would be the vertex angle. So the vertex is that top point, and the vertex angle is formed by the legs and the vertex. In an equilateral triangle, all three sides are congruent. And because the definition of an isosceles triangle says at least two sides are congruent, an equilateral triangle is also isosceles, which means that any properties or theorems that we prove are true about an isosceles triangle will also be true about an equilateral triangle. So the first theorem that we would like to prove about isosceles triangles is called the isosceles triangle theorem, and it says the base angles of an isosceles triangle are congruent. In other words, if I know that a triangle is isosceles, in other words, I know that it has two congruent sides, I can prove that the base angles, the angles attached to the other side, must be congruent. So here is the formal proof of why this is true. We are given some triangle LMP, and we are told that sides LM and LP are congruent. And our goal is to prove that angles M and P are congruent, the base angles of this isosceles triangle. So we're going to use a trick called drawing an auxiliary line. That just means drawing a line that's not originally part of the problem. And the reason we do that is so that we can use some of our triangle congruence rules. So the first thing we're going to do is just draw a midpoint. So we are told, let's let N, this point N here, be the midpoint of side MP. So we know that every segment has a midpoint, a point that is the same distance from each endpoint. So we're letting N be that midpoint. Next, we know that we are allowed to draw this auxiliary segment. So we add this segment LN into our diagram. And because we have 2 points determine a line, we're allowed to draw that segment in there. Next, we know that MN is congruent to PN. MN is congruent to PN by the midpoint theorem. The midpoint theorem says that a midpoint cuts a segment into two congruent segments. So that gives me MN congruent to NP. Next, I'm going to use the fact that any segment is congruent to itself. So LN is congruent to itself by the reflexive property of congruence. And finally, we are given that LM and LP are congruent when we are told that this is an isosceles triangle. So finally, we can say we have one pair of congruent sides, we have a second pair of congruent sides, we have a third pair of congruent sides, so these triangles are congruent by SSS. Lastly, once I know that the triangles are congruent, I am allowed to conclude that the corresponding parts are congruent, and we call that CPCTC. If I know that the triangles are congruent, I know that their corresponding parts are congruent. And now I have proven the isosceles triangle theorem, which says that if I know that two sides of a triangle are congruent, then I can conclude that the base angles are congruent. So if I know that I have congruent sides, I can conclude that the angles opposite those sides are congruent. But what if I know that I have congruent angles? Can I conclude that the sides opposite those angles must be congruent? And the proof is essentially the same idea. If I know that these two angles are congruent, and I draw an auxiliary line, and I can choose what kind of line I want to draw, I am going to choose to draw an angle bisector. So I'm going to bisect the vertex angle here so that these angles are congruent. And then I have reflexive property to show me that the angle bisector, or the segment part of the angle bisector, is congruent to itself. So this time I could use AAS, triangle similarity, can conclude the triangles are congruent. And then finally I could use that CPCTC. So in conclusion, I have two new rules. The first one says, if I know that two sides of a triangle are congruent, then I can conclude that the angles opposite those sides are congruent. And the converse says, if I know that the two angles are congruent, then I can conclude that the two opposite sides are congruent. So which of these rules helps us determine that the angles of an equilateral triangle are all 60? So this time I'm told that I have an equilateral triangle, which means this is congruent to this is congruent to this. So that tells me that these two sides are congruent, so I'm going to call them X and X. But it also tells me that these two angles are congruent, opposite those congruent sides. So if one is X, the other must also be X. And I can use the triangle angle sum theorem that says that the three angles of a triangle must add up to 180 degrees to solve here for X. 3X is 180, and I can divide by 3 to get that X must equal 60 degrees. So all three angles of an equilateral triangle must equal 60 degrees. So the last thing we're going to do today is to apply the Isosceles triangle theorems to solve problems involving angles. So here we are given three angles, 52, 6y minus 2, and the 4x plus 20, and I know that these are the three angles of a triangle. So I could add them all up to be 180, but then I would still have to find what x and y are. So the other thing I can do is recognize that if these two sides are congruent, wx and wy, that means that the angles opposite those sides must also be congruent. So angle y is congruent to angle x. So that gives me a lot of information. So there are two ways to do this problem, and you might want to pause the video and see which way works for you. One is definitely more complicated than the other, so see if you can figure out the shortcut way, and then unpause the video and see which way you decided to do. So the first one involves a system. We could say 52 plus 6y minus 2 plus 4x plus 20 has to equal 180. And then, because those two right angles have to be congruent, we could also say 6y minus 2 has to equal 4x plus 20. And we could do that. We could solve this system of equations, but it is definitely a more complicated process than solving a one variable equation. So the other thing we might notice is that if 52 is the vertex angle, that means that the two base angles must add to, let's see, 180 minus 52 is going to leave me with 128. And then I need to share the 128 between the two base angles equally. So that means that each of those base angles must equal 64 degrees. So this angle is 64 and this angle is 64. And this gives me a much simpler set of equations to solve. I know that 6y minus 2 equals 64, and I also know that 4x plus 20 equals 64. And when I solve each of these, let's see, I get 6y equals 66, adding 2 to each side. Divide by 6, I get y is 11. And for x, I'm going to subtract 20 from both sides to get 4x is 44. and then divide both sides by 4 to get that x is also 11. So I can either use the isosceles triangle theorem to show that the base angles are congruent, and then use the triangle angle sum theorem to subtract the 52 and share the 128 degrees equally, or I could set up a system and solve it that way. Either way, I am using two rules. One is the triangle angle sum theorem, which says that three angles of a triangle add up to 180 degrees. And the second rule I used is the isosceles triangle theorem, which says that if I have an isosceles triangle, then the base angles are congruent. So my two objectives today were to prove properties of isosceles triangles and also to apply them. So we said that if two sides of a triangle are congruent, then the base angles, the angles opposite those sides, must also be congruent. And we also said that the converse is true. If I know that two angles of a triangle are congruent, then I can conclude the sides opposite those angles are congruent. We also said that an equilateral triangle, using those rules, must have 60-degree angles. So if I know that a triangle is equilateral, I automatically know that all of its angles measure 60 degrees.